All right, welcome everybody. Today we welcome Mike Salvatore all the way from Pennsylvania, where he is a tech lead and security engineer on the Ubuntu Security Team at Canonical, with a bachelor's degree in electrical engineering from Rutgers and a master's in cybersecurity from Johns Hopkins. His passion is in all things security. So everybody, please welcome Mike. He's going to talk to us about regular expressions tonight and how we can use them for probably a lot more than we ever thought. Mike, take it away.
Hey, how's everyone doing? Just give me one moment here while I get this screen sharing working. All right, can everybody see this?
Yes.
Okay, I probably should have started at the beginning. Okay, so there's only 6 of us, myself included, on this call, so I'm going to run things a little bit more informally, I think. Feel free to just chime in and turn your microphone on and ask a question if you have one. I can kind of try and monitor the chat, but on my laptop here, I can't fit everything on the screen. So the title of this talk is Do More with Less, right? An Introduction to Regular Expressions. And regular expressions are cool. As Nicholas said, I'm passionate about all things security, but I'm not talking about security tonight. Really what I'm talking about is this do more with less and how regular expressions can sometimes be a vehicle for that. Nicholas gave us all this information already, but like he said, I'm a security engineer on the Ubuntu Security Team at Canonical. If you have any questions about this presentation or anything else and you want to follow up after, please feel free to reach out to me. You can email me, mikesalvatore@canonical.com. So again, for this presentation, I have kind of 2 goals. The first goal is more on the side of soft skills, right? How do we become better technologists? How can we do more with less? And then after that, I can kind of get into some of the little bit more dreary, boring, like these are what regular expressions are, the technical meat is a hard skill that you can actually use. What got me thinking about this presentation was in our PA Hackers chat, which PA Hackers is a group for people in central Pennsylvania who are either security professionals or enthusiasts. Oh no, that is a typo. It is Canonical. Thanks for pointing that out. So PA Hackers is a group of loosely knit security professionals and enthusiasts in central Pennsylvania. And in our group chat, one of my good friends said, hey, I was trying to get these transcripts off of YouTube videos, but when you copy and paste them, you get these timestamps on every other line. So to give you an idea of what that looks like, if we wanted to share Chris Crocker's vision for the world that we all can just be a little bit nicer to each other, and maybe we can start by leaving Brittany alone. You can see on the right, YouTube has some automated system that will try and write a transcript of everything Chris is saying. And on the left, there's a timestamp that tells us when he said it. But if you try and copy and paste this into text, you get something that looks kind of like this, right? You get a timestamp on every other line, and it's kind of difficult to read. You just don't need that superfluous information in there. So my friend, being the good guy that he is, said, I wrote this quick little Python script that just takes every other line. If anybody else thinks it's useful, here it is. So here's this script. It's 7 lines. All it does is it takes an input file, it opens up an output file, and then it reads every other line, and it only prints out every second line. So in this way, it skips all the lines with the timestamps, and it just spits out just the text. Much better. But see, I'm on this quest. I would like to become a 10x engineer. Now, I'm not a 10x engineer. I'm probably not even a 2x engineer. Maybe on a good day, I'm a 2x engineer, but most days, I'm still on this quest, right? And if you haven't heard of a 10x engineer, there's a little bit of controversy around the term, which I'll talk about later. But for the moment, let's just say that a 10x engineer is an engineer that can accomplish 10 times the work of other engineers in the same amount of time. I mean, that's pretty great. And that's something I think we should all try to aspire to is, to be the best and to be able to do so much more than everyone around us. But there's kind of a little bit of a trap in there that I think we all have to be aware of. And the trap is thinking that if my friend wrote this 7 lines of Python, to be a 10x engineer, I have to write this 7 lines of Python 10 times faster. But I think the trick that separates a lot of regular engineers from this mythical 10x engineer is that the 10x engineer recognizes when there's a faster way to solve the problem. Rather than trying to do the same thing faster, you just circumvent the original solution and go at it a quicker way. So this line down here that you would usually type into your bash terminal on a Linux system, this was my solution, is using grep and a regular expression in order to strip out those timestamps. And I thought I was clever until I researched it a little more, and I found out that awk, which is another text processing utility, can do it like this, which is a little bit more clear if you know what you're looking at. It's basically the same trick the Python script is using. It uses a modulus to only print out the even numbered lines. Better solution than my regular expression. But everybody that was in this conversation felt pretty silly when we all realized that you could just go to YouTube and turn off the timestamps, and then you don't have to jump through any of these hoops, to write Python or regular expressions or use awk in order to strip these timestamps out. So sort of a key takeaway from this is that the best engineers, first and foremost, read documentation. If you can spend a little bit of time, invest a little bit of time reading documentation, you'll often find that the problem you're trying to solve has already been solved. This is going to save you bundles and bundles of time. The next thing to think about is generalizing the problem. You don't always want to think about it as something so specific. It's not just about timestamps in YouTube transcripts, right? I mean, what is it at its core? It's data, right? And I want to manipulate that data. Now, we can specify that a little bit more. And we can say it's textual data and I want to manipulate text. But if we're able to generalize the problem and recognize that it's not quite as specific as we originally thought, then we can identify the best tool for the job, right? Which maybe is lines of Python, but it might also just be grep or awk, right? These are text processing tools. If you can use a text processing tool to solve the problem, then you can do things much faster. So when I say 10x engineer, and when I say can do 10 times the work in the same amount of time, this is kind of what you picture in your head, right? It's Superman, able to leap tall buildings in a single bound and able to write entire operating systems in a single weekend. And while those people do exist, and while they are, the helpers of mankind, most of the people that I have met that can do this really are a little bit less Superman, and they end up being a little bit more Lex Luthor, right? Not so much savior, a little bit more evil genius. And in the industry, we've started calling these kinds of people brilliant jerks. And the problems with brilliant jerks is they make everyone around them feel stupid, not because they're so smart, but because they're hypercritical, right? People and teams and projects become so reliant on these kinds of people that if something happens to them, if they quit, if they win the lottery, if they get hit by a bus, now the whole team is kind of up the creek without a paddle, because it was all reliant on this one person who was, fixated on being the best to the detriment of everyone around them, didn't share knowledge, just, churned out as much code or as much, whatever as they possibly could. So what if a 10x engineer isn't just someone who can do 10 times as much? What if part of doing 10 times as much is enabling the people around you to do 10 times as much? So this is why my friend shared his solution in the first place. Hey, this Python code might be useful to anybody else. That's why I shared my solution back, right? Hey, you could do this with grep and regular expressions. So with that, we're going to talk a little bit about regular expressions, and I'm just going to take a peek at the chat here to see what I missed. Yeah. Just silly banter. Okay. So like I said, this is my solution using a regular expression. It takes the text on the left and strips out these timestamps and turns it into the text on the right. Now, to get a more intimate look at how it does this, if you're not familiar with grep, like I mentioned, it's a tool. It searches for patterns in text files. I'm passing some options to grep in this point. I'm passing some options to grep. And these are super important. The -v inverts our match. So normally grep shows you all of the text that matches your pattern. But in this case, we're asking grep to show us all of the text that does not match our pattern. The second parameter is just using Perl compatible regular expressions. And there are a number of different regular expression engines. They all do about the same thing. They have little differences, little quirks, but the Perl compatible regular expressions engine is just one example of a regular expression engine. This here is my regular expression. It's a string matching pattern, and I'll break it apart in just a moment. This is my input file, right, my YouTube transcript, and this is my output file, which is where my text without timestamps is going to be saved. So my regular expression is pretty simple. It starts off with this caret, and that means the beginning of the string. Jumping to the end, it ends with this $, and that means the end of the string. And you're going to see this pattern in regular expressions quite a bit. And what it's saying starts with a caret, ends with a $, is I want the whole line of text to match this expression, not just a subset of the line, right? The whole line from start to finish needs to match this expression. The next thing in there is \d, which is regular expression for a digit, any digit. And the 2 in curly braces means whatever the character that came before is, in this case a digit, I need exactly 2 of them. So I need exactly 2 digits, followed by a colon, the actual character, a colon, followed by any 2 digits. So if we look at the first line of our transcript text, we can see it's 0, 0, that's 2 digits, colon, 0, 0, right? Start and end of line. That's the only text on the line, 2 digits, a colon, and 2 digits. It matches our regular expression, but we've passed the -v to grep to invert our matching. So because it matches the regular expression, grep is going to ignore it. The next line, grep checks whether or not it matches our regular expression. Well, it starts with an H, which is not a digit. So our regular expression says it has to start with a digit, so that doesn't match. And so on and so on and so forth until we take the text from the left and we get the text on the right. When you're learning regular expressions, it's super useful to have a cheat sheet at hand. There's a bunch of different cheat sheets out there. You just Google regular expression cheat sheet and you'll find one that looks like this. I have found in my experience that probably 90% of the regular expressions I write, maybe even 95% of the regular expressions I write, use just this highlighted in orange subset of your regular expression cheat sheet, right? Most of the power in regular expressions is in a handful of features. And then all the extra features let you do crazy, insane, cool things with regular expressions. But most of the time, it's sort of one of these simpler things that you're going to end up using. So to introduce you to some of these different parts and pieces that make up regular expressions, I have a couple of examples. The first example is, again, you notice starts with a caret, ends with a $. So I'm saying I want the whole string to match, the whole line from start to finish. The first character I want to match is a dot. Now in regular expressions, the dot or the period, that's like a wild card. It means any character with the exception of a new line character. So this regular expression says I want my whole line to match any character followed by EAT. So it'll match things like beat or meet or heat, right? Lowercase or uppercase on any of these. But it's not going to match the word eat, right? E-A-T, just all on its own. And the reason is because my expression has said I need any character followed by EAT, but just EAT on its own doesn't match that pattern. Similarly, great, G-R-E-A-T, has 2 characters followed by EAT, and it doesn't match our pattern. Now, heated has H, 1 character, EAT, so that matches, but it ends in ED. And since I've specified my caret and my $sign, right, I'm saying the whole line has to match. So this extra ED on the end does not match my regular expression. If we introduce some quantifiers, we can start to do more interesting things with our regular expressions. So the only difference between these 2 regular expressions is this asterisk. And what that asterisk says is whatever character came before, I can have 0 or more of those. So in this case, now my regular expression matches the word eat all on its own, because I can have 0 or more characters preceding EAT. It also matches beat and heat and meet, all the same things it used to match, but now it matches great, G-R-E-A-T, because I can have 0 or more characters, in this case 2, before EAT. In fact, I can have any number of characters, right, and end up with this sentence, an angry sheep will bleat, right? Because effectively, this regular expression just says, whatever my string is, I need it to end in EAT. There's lots of different quantifiers, and I think, truly quantifiers are one of the most useful, one of the things I use most, in regular expressions. This quantifier, the plus sign, says I can have 1 or more. So whereas the asterisk said 0 or more, now I can have 1 or more. So all the same things from the last regular expression match, with the exception of just EAT on its own, because again, I need to have at least 1 character that comes before EAT. These 2 regular expressions are equivalent. They do exactly the same thing, but they use 2 different kinds of quantifiers to do it. They both match the words bot or boot. Whereas the first regular expression says, I need the letter B, then I need the letter O, and then it has these curly braces with these 2 numbers inside it. And it just so happens those 2 numbers are right next to each other, but really those numbers are a range. So you can see in the cheat sheet, it has curly brace 2, 5, right? It's between 2 and 5, at least 2, but no more than 5. In our case, I'm saying I need B, and then at least 1, but no more than 2 O's. So that matches B-O-T or B-O-O-T. The second regular expression matches the exact same text, but it does it using the question mark instead. So whereas the asterisk said 0 or more, and the plus sign said 1 or more, the question mark says 0 or 1. So the regular expression can have B followed by O, followed by 0 or 1 O's. So that second O can either be there or not, and ending with a T. Character classes are also very useful. There's a number of already predefined character classes, right? You can have digits, white space, word characters, which are generally, letters, numbers, and an underscore. But we can also kind of define our own character classes. There's not a predefined one for just letters. So using A through Z, capital A through capital Z, and lowercase a through lowercase z, I'm able to say, I want letters. So the sort of scenario here is, let's say I have a website and I want users to register with usernames, and I want to make sure the usernames they provide are valid. I'm going to define a valid username as any number of letters followed by 1 or more digits. So it has to start with letters and it has to end with at least 1 digit. So this regular expression in those square brackets says I can have any letter. The plus is 1 or more. The \d is digits, and then again a plus for 1 or more. So I can have 1 or more of any letter and then 1 or more of any digit. Yeah, so the period does match special characters, numbers. It's anything except a new line. Regular expressions can be super simple. right? Like most of the ones we've seen are fairly simple. This one checks whether or not a string represents a positive or negative integer. I'm defining, a set of characters that are allowed in those square braces, either plus or minus. My question mark says I can have 0 or 1 of those, right? So if I have 0 of them, that implies positive, or I can have a plus to explicitly say it's positive, or a minus to say it's negative. Then that's followed by 1 or more digits. Regular expressions, however, can also be stupid complex. This one validates email addresses, and just don't ever do this, right? Unless you have some kind of magical Rain Man regular expression skill, you're not going to be able to figure out what this regular expression is doing. And importantly, if we want to enable the people around us to do 10 times as much, whoever comes up behind you and has to deal with this regular expression is not going to be able to do 10 times as much. In fact, they're probably going to be able to do, I'm estimating, 100 times less. And probably the first thing they're going to do is rip out this regular expression and replace it with the code that you should have just written in the first place. So I guess kind of the last thing I'm going to leave you with is a real example of something that I had to do at my job. On the Ubuntu Security Team, we deal with CVEs quite a bit, and a CVE is really just kind of like a registered vulnerability. Each vulnerability gets an ID, and it looks like it does here on the slide. It starts with CVE, then a dash, then the year that the CVE or the vulnerability was discovered, then a dash, then 4 or more digits that uniquely identify the CVE in that year. Some things to note, the first CVE was created in 1999, so there are no CVEs from 1998. And obviously it's 2020 as we do this presentation, and unless you have a time machine, you're not going to be able to find any CVEs from 2021 and beyond. So CVEs with those numbers for the years are not going to be valid. So I wrote up this Python code. On the left, there are 23 lines of code, 23 lines of actual code that perform validation of a CVE ID. And on the right-hand side, there's a main function that runs a bunch of potential CVEs through my function and checks whether or not my function thinks that they're valid. Now it's 23 lines, it's not super long, and it's kind of pretty easy to see what's going on in here if you've ever programmed any Python, right? The first thing I'm going to do is I'm going to break my CVE up into parts on line 2, and then I'm going to check to make sure I have exactly 3 things, right? Any more or less, if I don't have the CVE, the year, and the identifier, if I don't have exactly those 3 things, then it's not a valid CVE ID. Then I'm going to make sure the first part is the letters CVE. And then the next thing I'm going to do is I'm going to try and convert the middle portion into an integer. If it's not all letters, what's going to happen is that call to int on line 11 is going to raise an exception, and the code's going to hop down to line 21 and 22, where it's going to say this isn't valid. Back up on line 12, if it was a valid integer, I'm going to make sure that it's between 1999 and 2000. Anything before is invalid, anything after is invalid. The last thing I'm going to do is I'm going to look at that identifier portion of the CVE. I'm going to make sure it has at least 4 characters, and then I'm again going to try and convert it into an integer to make sure that those characters are integers, right? To make sure that I don't have periods or letters or anything in my CVE ID. And so on the right, you can see all the funky things that are kind of CVE IDs that I've plugged into this, right? You have hello for a year. I have things from 1998, something from 2021, right? And the function decides whether or not it thinks those things are valid. Okay, so 23 lines of Python code, and we can do this. But we can do it a little bit simpler with a regular expression. The simplest regular expression that we can use is we can just say CVE and then exactly 4 digits and then 4 or more digits. So those curly braces on that last section, they have 4 and then a comma. So that comma just means or more, because I haven't closed the range. Like unlike when we had 2, 5 or 1, 2 and I closed my range, in this case I've left my range open-ended. So that's good. We can make our regular expression just a little more advanced by including information about what years are valid in that years section of the CVE ID. Now, parentheses have a specific use in regular expression. They're for grouping, and they help you pull text out of CVEs for determining like portions of your pattern that match portions of the text. But in this case, I just have them here for clarity and for group to just kind of, like you would use them in math. So again, I can have CVE, and then I can have 1999, or, and that pipe symbol is the or. Yeah, Adam, you're onto something. How tricky would it be to get a date and use the current year? Yes, you have to update this code every year, and I'll get to that a little bit. So in my year portion here, I can have 1999. The pipe symbol means or, and then I can have 20, a 0 or a 1. There's one of my, custom defined character classes there in the square brackets. I can have a 0 or a 1 and any digit. So I can have 2000, 0 through 9, so 2000 through 2009, or 2001, 0 through 9, 2010 through 2019. And finally, I can have a year 2020. Then it ends with the same as the above regular expression, right? 4 or more digits. When you change from trying to do this validation in code to doing it, checking whether the CVE matches a regular expression, you go from 23 lines of code down to 4 lines of code. So not only do you have to write less code, you can write less code quicker. But more importantly, if we find out that there's a bug in our validator, I can tell you exactly what line that bug is on. Because I mean, really, there is only one line in this function. It's the regular expression. I know exactly where to go and look for that bug. If I told you there was a bug in this function, it's going to take you at least 23 times longer to find it, right? Or maybe not 23 times longer, but there's 23 lines that you have to consider. You're going to be able to find that bug quicker if you've written less code and it's concise. Now, like we saw with the email regular expression, you can write regular expressions that are worse than code, right? I mean, don't do that. Don't write crazy, insane regular expressions that are going to be difficult to figure out and debug, unless you and all the people you work with are, regular expression gurus, in which case go at it, because that's, regular expressions is a language that you all speak very well. So yeah, as Adam alluded to, both of these functions have an issue, which is that next year I'm going to have to update my code because these only match up to 2020. So bonus points for anybody who wants to come up with a solution using either regular expressions or code, but more likely a combination of both, to produce a validator that's concise, and also I don't have to update every year. If anybody thinks that would be fun to tinker around with, feel free to email it to me. Finally, as you are playing around with regular expressions, I can't recommend enough regex101.com. When you punch your regular expression in, it's going to break it down piece by piece and explain to you what each thing in the regular expression is doing. And then it's going to let you put strings in the test area, and it's going to let you know whether or not those strings match. So it's super useful if you're debugging a regular expression, or if you're learning regular expressions and you're trying to figure out, hey, is this going to behave the way that I think it's going to behave? And with that, I'm going to open it up for questions.
So do you have or is there an example you can give us of something that we could do with regular expressions that doesn't necessarily involve, well, specifically parsing text?
I mean, regular expressions are for parsing regular languages, which in my experience has all been text. I'm sure you could abuse them to make them do other things, but at least as far as my understanding goes, they're really just about checking whether or not text matches particular regular expressions, right? It's about identifying matching text.
All right, thanks.
But you know, a lot of the data that we work with is text, right? I mean, we're human beings, and human beings consume lots of text.
There's a question in the chat. It says, do you know any sites that offer good examples to practice with?
There's a lot of regular expression sites out there. As far as examples to practice with, I can't think of any off the top of my head. There was one, was it regex T-rex or something like that? There was a lot of interesting, yeah, rexegg.com. So I'll put it in the chat here. This website has a lot of really interesting information about regular expressions. They have, 100 uses for regular expressions, cheat sheets. So you probably can find something on there that would help you practice. Oh, apparently I'm typing privately here. You have to forgive me. I don't use Zoom a whole lot, being a security guy.
All right, do we have any other questions for Mike? All right, I'll take silence as contentment. Mike, thanks for coming out. I really appreciate you bringing this topic to us and educating us more on regular expressions.
Yep. Have a good night, everyone.
Thanks, Mike.